So next we have diffraction of light. So they have diffraction of light. What is diffraction of the bending of light around the edges of an obstacle? The bending of light or bending of light around the obstacle of an edges of an obstacle, around the edges of an obstacle. Around the edges of an obstacle is known as diffraction. Is known as diffraction. Okay. Here, around the obstacle is known as diffraction. Clear? What are the two conditions for diffraction? Anyone? Charger person? I know.
So the edges must be smooth.
Yeah, hello, how are you?
Thanks, sir.
What happened? Order finished? Order khatam ho gaya? Order. Did not place the order still?
Yeah, orders.
Then. Why did you do that? I told you not to do that, right?
So only India people are going to.
Okay, anyways, let me go ahead. So here there are two conditions for diffraction. Conditions for diffraction. Conditions for diffraction. The first one is what? The size of the the size of the obstacle. The size of the obstacle or the aperture should be, or the aperture should be of the order, should be of the order of the wavelength, of the incident wave, This is the first point. Once again, the size of the obstacle means aperture, or the aperture should be of the order of the wavelength of the incident wave. The second one is here, that is the separation between the obstacle and aperture. Is that clear? That means what? Suppose this is the aperture, like suppose this is the plate. We are taking a glass plate actually. Glass plate, we black it completely, and then we make a small hole. Means like see, we make it completely black. Okay, we make it completely black, and then what we are going to do is now we make it a small hole on that. So that will become a like a diffraction. So that will become a aperture. Okay. Second one is what? The separation between the obstacle or aperture. The separation between the obstacle or obstacle, the separation between obstacle or aperture and the screen, or aperture and the screen and the screen should be considerably larger than considerably larger than the size of the obstacle, the size of the obstacle, or aperture. These are the two conditions. Okay. So first one, what is that? Whenever I say aperture, it's like a hole. Means what we do is we take a glass plate, paint it completely dark, and make one small dot. It's like pinhole. That much small hole will be there. Otherwise, we'll make a slit. Okay, slit means what? Like this, small like this. This is completely dark, and we take a blade and just remove that much paint on that one. So that will become slit aperture. So this is circular aperture. This is slit aperture. Slit means only one line. Double slit means 2 lines. Okay, diffraction grating means number of lines. So many lines will be there. Thousands of lines will be there. With the blade or with the tip of this is done by tip of the diamond. This thing is done by the tip of the diamond. Okay. Here, please note down this one. Are you able to see the screen properly, all of you?
Yes, sir.
Okay, great.
So,
Yes, sir.
See, once again from the beginning. See, this is a slit. Ln is a slit. Okay. Now, this light is coming from the source. We have taken a point M in at the center. Again, the center of Lm is M1. The center of Mn is M2. Now, these light rays are going to point P. Clear? Now, these are the rays which are going straight to C. Is that clear? This is angle theta. This is angle theta, and this is also angle theta. Now, these are 10 rays, 12 waves, and this is 14 waves. Example. So if I want to take exactly same 10 here and 10 here, okay, then this is what? This value will be how much? 4. Okay, यहाँ से यहाँ तक 10 waves है. Suppose like this. Suppose here, if the number of waves here, it is 10 wavelengths, 10 lambda. This is 12 lambda, and this is 14 lambda. Understood now? Example I am taking. Is that clear? So what will be this? If suppose from here to here, if it is 10, the remaining will be how much here? 4. No. Are you understanding? Please reply. Yes, Ismail, Arham.
yeah. Yes, sir.
Moksha.
Yes, sir.
Yeah, Ashas, what is the relation between phase difference and part difference? Are you there? Ashas? Where are you? Okay. Now, yes, Moksha, did you understand this one? So this is 10 lambda, 12 and 14 lambda. That extra is what? This is 4. The total from here to here is 14. So the extra
Yes,
is
sir. Yes, sir.
Understood now? So that
Yes, sir.
So it makes a right angle triangle now. This makes a right angle triangle. Understood? This makes a right angled triangle. So what is the formula here? Now we are writing here NP minus LP. See, this is NP minus LP is equal to what? NQ. Okay, equal to what? NQ. So what is the formula here? We have this is theta. This also will be theta. Okay, this also will be theta. Is that clear? Are you understanding?
Yes, sir.
Yeah. So therefore, what is the formula now? Sin theta is equal to opposite side by hypotenuse. What is opposite side? NQ. And what is the hypotenuse? Ln. Okay, Ln. So what will happen now? Cross multiply. NQ is equal to what? Ln sin theta. Okay, Ln into sin theta. What is the Ln? NQ is equal to A sin theta. Understood now? NQ is equal to NQ value is equal to what? A sin theta. If theta is small, what will happen? Sin theta will be equal to theta. Understood now? So in that situation, what will happen? In that situation, NQ will be equal to what? NQ is equal to A theta. Got it? NQ will be equal to A theta. Is it clear, all of you?
हाँ sir.
Yeah. Now the next one is suppose. So NQ is equal to what? A into theta. So now we have here no, this is what this is said to be central maxima. Maybe this is first order, second order, whatever it is. Okay. If you look at the diffraction pattern, how it is, if you look at on the screen, how it is, so this central one will be bright like this. This will be the first. This is the first order like this. And this will be the second order. Okay, this is central maxima. First order, second order, first order, second order. Understood now? Central maxima. This is central maxima. These two are first order. These two are the second order. So what happens is the central is having more brightness when compared to the first, then when compared to the second. So this having more brightness as well as its thickness is also, that means the fringe width is also more. And when you go to the second one, the first order, the brightness also will reduce and the thickness or the fringe width also will reduce. Okay, that is how it keeps on going.
The width.
Did you understand?
Yes sir.
Okay. Now here we are going to the second case now. Well, the second case is here. Okay, theta here. What did we get here? Theta is equal to n lambda is equal to theta. So therefore, next one. Suppose MP, M and M1, M2 are the midpoints. M1 is a midpoint of LM. M2 is the midpoint of MN. Okay. So what happens here? M2P minus M1P is equal to M2P minus M1P equal to what? Is equal to Y into theta. Y into theta. So what is Y here now? The total value is A. Half of that is what? Y is equal to what? Y is equal to A by 2. Is that clear now? Same formula we are applying. Okay, is that clear? We are applying the same formula. NQ is equal to what? NQ is equal to A sin theta. Same thing we are applying the same situation now. M2P minus M1P is equal to NQ. Means if the rays are coming from here and if the rays are coming from here, then the path difference will be how much? Path difference, not phase difference.